In this video, we're going to practice writing quadratic functions given table using technology. So Amory recorded the distance and height of a basketball when shooting a free throw. So today we're going to practice putting this into the calculator just like we did for linear regression. We're able to put a table into our graphing calculator, and from there it can give us all of the information we need to write the equation. So first we're going to click the plus sign and we're going to choose table, and we're going to enter our table exactly the way it is given to you. So you don't want to skip any values, and you don't want to stop before your entire table ends. So enter all of your x values, all of your y values correctly. And so from here, what this does is it allows you to graph, and it plots these points for you. As you see, I'm plotting each point, or I'm entering my x and y values. It's plotting it here on my graph to kind of come up with that quadratic function of when she began throwing the basketball up and shooting it. Once you enter your entire table from the notes, on the second tab, you are going to find the linear regression. In order to find the linear regression, you want to use that information. Here's what I need. Excuse me. Remember that your standard form of a quadratic function is y equals a x squared, where a is a value in front of x squared, plus b x, and plus c. So c is that constant. So what you want to recognize is that we're going to have to identify what a, b, and c are in order to write our equation. So in our table, after entering it, we're going to use y1. The symbol you need is here, ax1, and then you need to square it because we're talking about quadratics, plus bx1 plus c. So you want to use that standard form to kind of help you remember where x and y are those points on your graph. So once you do that, you're going to notice r squared this time. Usually before we were looking at the correlation coefficient. Now we're looking at r squared because you're talking about a quadratic function. So x needs to be squared. So we're looking at the statistics for r squared. So when r squared is really close to 1, it gives you an idea of how close this is to a nice parabola. It's not going to be exactly 1 because our data is a little off, but you can see, you want to understand that your graph is restricted to the positive x values and positive y values. Your x values represent the distance, and then the y values represent the height. So you can see that she began at about 4 feet and threw the ball up, and then it landed about, you can say, 20 feet from her on the ground. So you can make all these predictions from graphing it in your calculator. What you're going to need to do is actually type the equation. Y equals, so here, type y equals a. You're going to notice right here, you need all of this information over here off to the left from your table, or so you can write the equation. So a is negative 0.117, negative 0.12, negative 0.12x, and then you need to square that. Let me erase this piece. So you can use your caret symbol squared, or I'm going to go ahead and insert my superscript 2, x squared, format text. B is 2.11, so I'm going to add 2.11x, and then C is 4.21 plus 4.2, and we'll round up to 2. So this is going to be the equation of my graph. You're going to notice that x is squared because it's a parabola. There's a negative in front of here because our graph is facing down, so parabola is going down, and your y-intercept is going to be at 4. It's not exactly 4 when we put it into the calculator, but you're going to notice right here 0, 4, that tells you where it intersects on the y-axis. And you can make predictions from here. So if you wanted to figure out the distance at 4 feet, so you can enter that in your table, or you can take this equation that we just came up with, y equals negative 0.12 x squared plus 2.11 x plus 4.22. And it's not going to be exact because the equation we came up with is based on the information from our table. So after that, if we wanted to pull up that table for that specific graph to look at when x is 4, what is the y value? What would the height be? 10.7, about 11. So when the distance is 4 feet, we could say that height would be at about 10.7 or 11 feet high. Okay, we're going to do one more example, and we'll show you again how to go through this and make predictions. You can make your predictions using your graphing calculator, or you can also just plug in the value. So here, the table shows the run times in seconds. A certain computer program requires to analyze the given megabytes. So here's your table. This is a table we're going to enter. Put a plus sign, table, enter your values 1, 2, 3, 4, and 5 for x. 1.3, 3.3, 6.7, and 10.7, and 16. So you're going to see it's showing that parabola because we're talking about the run times in seconds and a certain computer program with the megabytes. You want to graph that data and find a quadratic function that provides a reasonable fit. So we're going to go ahead and type y1 not equals, excuse me, you need to use this symbol, ax1 plus bx1 plus c. Oh, you need to go back. Make sure x1 is the first piece. It should always be squared because this is a parabola, this quadratic function. Do not forget to square that first part there. So here r squared is very close to 1, so that means this is strong data to come up with a quadratic function. And again, you want to think about your graph is going to be restricted this time. This time it's a parabola facing up, so it's restricted to only the positive and x values and y values because you cannot deal with negative time, negative megabytes. So here you're given a is 0.51. So in order for you to write the equation, let me go ahead and write the equation. You're going to type the information from your table. Y equals, since a is 0.514, 0.51x, and we're going to square it. B is 0.59, 0.59x, and C is 0.16, 0.16. And from here, this would be the equation you can use to estimate the runtime to analyze when 3.5 megabytes of data is used. So from here, I can take this equation that I just came up with and graph it in my calculator. I'm looking for 3.5 megabytes, so I'm plugging that in for X. You can actually just plug that in to figure out the Y value. So 0.51 times, if I'm plugging this in for X, 3.5 squared, because this is my X squared, plus 0.59. Instead of X, I'm going to plug in 3.5. And then last, plus 0.16. So about 8.47, 8.5 would be the runtime to analyze the data. So here, about 8.5, and we're talking about time in seconds, to analyze 3.5 megabytes of data. Now you're going to go ahead and practice on your own. If you have questions, please make sure you join Zoom and ask your teacher.